Hello and welcome to Identity Office Hours. I'm your host, Mike Schwartz, founder of Glue. Today is episode 219. Quick reminder, please follow IOH on LinkedIn or YouTube. And now, as of the last couple of weeks, on Spotify. We're putting new episodes on Spotify, and on the weekends, we're publishing some best of episodes. The topic today is Agent Gateway. Keep infrastructure out of your AI agents. Our guest today, as you can see, is Christian Posta, Field CTO of Solo.io. Welcome, Christian.
Thank you, Mike. Thanks for having me. Thanks for the invite. Big fan of this program, so look forward to the discussion.
So before we dive into it, somehow this is your first episode, which is hard to believe. But maybe before we dive into it, you could tell us a little bit about your background.
Sure. Yeah. So I'm been at Solo.io for the last almost 8 years now. I was at Red Hat before that, and then small open source integration company FuseSource got acquired into Red Hat, and then big banks and enterprises and all that stuff before. So I've been around a little bit. Working at the big companies, I got to see the reality of what that is. Then my open source time. And then, at Solo, I was employee number 10. It was me, Adit, and 8 engineers, and we built the company to what it is now over the last 8 years. So, it's been a ride.
So, I have an open source software business models podcast called Open Source Underdogs, and Adit Levine was one of the guests a couple of years back.
That's great.
So, yeah, it's has really strong open source roots, and ironically, Solo.io was a company that just from a branding level, we couldn't figure out how to partner with at Glue, because Glue has a product called Solo, which is our hosted product. So we have Glue Solo, and then you're a company called Solo, and you had an API gateway called Glue.
That's right.
It just seemed like it would be massively confusing to try and figure out how we would ever market. So
that's funny, yeah.
But the topic today, actually, luckily, you guys keep shipping and building new products, and this new one is super interesting, called Agent Gateway, contributed to, and I always get this wrong, the AAIF.
Very close. AAIF, yeah.
Okay, I don't know why I'm incapable of remembering. Let me give the Linux Foundation, Agentic AI Foundation, the AAIF, and so it's one of the first projects that I guess AAIF has accepted. AAIF is the home of MCP. So I guess Anthropic contributed it to Linux Foundation, and this is sort of the core, I would say, the core asset. And also this sponsor of a bunch of great conferences, or there's one coming up, I think, the end of October, maybe 22nd or so, in San Jose, MCP Dev Conference, AAIF conference, which I thought would be.
There's one before also. There's one right in Amsterdam in September, in a few weeks.
There have been a lot. There's been like 3 in India. There's ones in China. I mean, they're really going all out with these conferences. Actually, just a short time ago, I spoke at the MCP Dev Conference in New York City in, I think, I want to say April.
Yeah, that sounds right.
Yeah. And that one was great. Like I thought it was going to be a bunch of geeks, like I was like, no one's going to show up to this thing. And then like there was like 1,500 to 2,000 people there. So
yeah, I couldn't make that one. It's my daughter's birthday. I didn't want to miss that. So, but I'd heard, I had the FOMO.
Yeah, it was really, really good conference. I was blown away. But so let's talk about Agent Gateway, written in Rust, I hear. Which we're a big fan of Rust here. The Cedarling is built in Rust. Cedar engine, the canonical Cedar engine built by Amazon at the CNCF, is also in Rust.
Mm-hmm.
But one thing that I've been thinking about is that, okay, we have API gateways, and then MCP comes out and we make MCP gateways.
Yeah.
And now we had another layer of abstraction. Now we have agent gateways, which call the MCPs. And I feel like the time between like these is like, it took a couple of years to get MCP gateways, then MCP comes out, and then 12 months later, we have agent gateways. In 3 months, are we going to have some other type of gateway? Or is this it for levels of abstraction?
I think so. Agent Gateway started off. Well, here, let me give you a little history and how we wound up there, because we had a project called Glue or Glue Gateway, like you mentioned, and that's
GLOO.
GLOO.
Clarity.
Yeah. And when we donated that to the CNCF, we had to rename it. We owned the Glue GLOO. I think the trademark for that, and it was our enterprise product name. So when we donated to the CNCF, we had to come up with a new name and give them that, So that got donated as K Gateway.
Oh, so I just put a pause in there because I want to say this is a really interesting point about open source. And the same exact thing happened to Glue GLUU, because we contributed our base code to Linux Foundation, but couldn't contribute our trademark, and therefore contributed it under a new name called Janssen Project. So this, I think, is the one mistake I think open source founders make, which is conflating the open source and the commercial brands. And it can be a very dangerous business problem later on if not handled properly. But sorry to interrupt. So Glue, GLOO, the commercial brand, gets donated to CNCF.
The open source project that backed. So everything that we do is open source. We have an open core business model, but the gateway, the API gateway that we built on top of Envoy proxy, we donated that to the CNCF as K Gateway. So if you go back and you're checking, API gateway from Solo is the K Gateway open source project. And like I said, we built that on Envoy proxy. That was actually our first commercial product, was this API gateway, and it was targeted specifically for cloud native style workloads, running in dynamic container environments, Kubernetes, and so on, where things like Nginx, HA proxy, you really had to fight hard to make that work. Envoy was built for that. So that's our API gateway. But some of our larger customers, probably about 3 years ago now, started going down the path of connecting their services, internal chatbots, early experiments to AI frontier models, OpenAI, and so on. And they were looking for, governance, guardrails, that kind of stuff around that communication. So we said, this just looks like an API. We'll just build this into our K Gateway project or commercial offering. And we started going down that path, and it was going okay. One of the shifts in, if we dig into the details of how an API call happens versus how a call to a AI model happens. API calls are usually, we want them to be as quick as possible. Request comes into the proxy, do some analysis of the headers, routing, policy enforcement and stuff, and then send it out as quickly as possible. With the AI models, we do have that routing stuff, but we have to look at the body a little closer. What model is this? Because especially if we're trying to abstract away some of the backend provider stuff, so we have to evaluate the body and deal with that a little bit more. So in Envoy, the way we built that was sort of an add-on to Envoy, and it would inspect the body, maybe do some guardrailing stuff, and then send it on. And the more features we were trying to add, things like caching and so maybe more advanced guardrails and other stuff that dealt with the prompt, the more we added onto this thing that wasn't Envoy. It's this thing that ran with Envoy. Envoy would basically call out to it. And it just didn't feel right. And then when MCP started to come out, especially HTTP based MCP. That's all in the body. And we realized we're building a proxy outside of Envoy to make this happen, because to make Envoy natively do it, we would have to change a lot of stuff. We estimated back, about a year and a half ago or so, that it would take about a year to make this work nicely in Envoy. And stuff's moving so fast, right? We don't have we're not gonna go dark for a year, try to figure it out, and then come back. And so that's when we started up the Agent Gateway project, specifically to tackle this LLM MCP, protocol and gateway problem. But we named it Agent Gateway, thinking we don't know what's going to be next. We'll start with LLMs and MCP. We don't want to name it those because that might change. So what is it? What does an agent use when it's, how do you implement an agent? You need to connect to the model. You need to connect to tools. You need to connect maybe to other agents. You may need skills. You may need whatever. But we wanted to pick a generic enough name that we'll be able to, whatever an agent needs, we'll try to figure it out. And so that's how we got to that. Now, do I think an AI gateway or agent gateway, is there going to be another layer, another thing? I don't think so, because I think the MCP thing is kind of hitting a point where it's like, oh, maybe we'll come back and do some more stateless stuff. Maybe we'll come back and look a little bit more like what people are used to. So I don't know. Things move so quick, but I don't think so.
Right. Yeah, our crystal balls are broken. No one saw half of this stuff coming in the first place. So the question that I always think about with gateways is, how do we know that the agent is going to bypass the gateway and connect directly to the model or to the API or MCP server that we're supposed to? So how does Agent Gateway handle that? Or is there an architecture that you?
As an architecture, yeah, it's an architecture, and there's a few different approaches that we see in the organizations that we work with, because when they're in agents that they build or harnesses that they use, third party, whatever, when those things are connecting up to tools and APIs and models or whatever, they started off not having any visibility. They want that traffic to go through some sort of control point. And they want as much of that traffic as possible to go through so they can see what's happening. They want to secure it, they want to control it, and so on. And so you can ask the developers to configure their Claude code or whatever to connect up through the gateway. You can, at the network level, if they're in the corporate network, shut off access to, the GitHub MCP, GitHub Copilot MCP remote MCP server. But and we do see people doing that. So you can't get to, for example, the GitHub MCP server at all unless you go through the gateway. But if you turn off VPN, go right from your laptop, then of course you can. So we've been working on this problem. I don't want to reveal too much because I think next week we'll announce more about it. But so from the desktop, from the workstation, from what users, how they're tiptoeing into AI and agents and so on, there's still a lot of work to do there. I would say on the server side, where you're deploying agents into a server environment, Kubernetes is a big one that we focus on, but any of the other container environments, even the things like Agent Core and some of these other environments, you have a little bit more control if you can control the platform or influence or configure the platform. For example, in Kubernetes, the right way to think about agents and how it's quite a bit different from microservices is, in a microservice environment, you deploy a container into Kubernetes. You're trying to secure the traffic that comes into that service, into that system. With an AI agent, you want to do that, but you also care quite a bit about what that agent is doing and what's leaving that system. And so a technology that we've worked on for the last 10 years called Istio, and about 5 years ago, it started off as a, hey, deploy a sidecar next to each of your applications and we'll try to control policy and stuff. We got rid of the sidecar. So in an environment like Kubernetes, you flip the switch for Istio. Nope, you don't see sidecars, you don't see anything, but it's there. And it's enforcing things like MTLS and encryption between services, where we've primarily focused on traffic coming into the services. We also have a very good control point for traffic leaving the services. And so if you want to lock down that this agent can talk to the OpenAI models or the Anthropic models or Gemini, whatever, only through this approved path and have mutual authentication on that path, agent identity and all that stuff, then you can do that. So in a controlled platform, it's a little bit more straightforward. In the open endpoint universe, it's a little bit less, but I think there's a lot of work going into that right now.
Yeah, I've heard some hacks in the around DNS too, like change the DNS name if you're serving DNS internally, change the DNS for Claude or Copilot and return your gateway instead. So it thinks it's talking to Claude, but it's not.
That gets tricky because of the certs that you want to trust for what is Claude.ai, what is their actual HTTPS cert. So that does get hacky.
Right. Okay. Would you say then that the point of the agent gateway is to increase observability of the agent, of what the agent's doing? Would you say enforcement is more important or observability? And how do you see that trend, maybe like the trajectory of that trend or the direction of travel in the future?
The organizations that we work with, I wouldn't say one's more important than the other. I think they would say you can't govern what you can't see. So let's at least figure out what's happening here. So the initial big win is get this control layer in place so that we can see what's actually happening, what is being used. And then once you can see it, then we can apply enterprise controls like, all right, well, this has to be authenticated, not just authenticated to GitHub. It needs to be authenticated to our internal IDP and stuff that we have internally to do that. We want to apply authorization policies. We want to apply usage and quota policies. If things go down, we want fallback policies. We want tracing. We want all the stuff that'll help. Like if things start to slow down unexpectedly or fail unexpectedly, we want to quickly be able to get in and figure out what's going on. So I would say then the first step is turn the lights on, and then once you can see what's happening, lock down the things. It felt like for a little bit there, AI and especially the MCP protocol, it got introduced. People got so excited about it. They started deploying it. And they're like, well, the enterprise was like, oh, yeah, well, we do security like this over here. And then the people, the AI who are using the MCP protocol, they're like, yeah, well, MCP doesn't specify that. So let's just keep going. I think that's starting to become a little bit more locked down. And, people are saying you can't do that. You can't run this here if that's, you're not going to adhere to the existing security principles and policies and so on. So I think see what's happening, and then we'll figure out how to lock it down. And a gateway is a great place to do that.
So how does Agent Gateway actually handle authorization? I would hope it's a consumer of policy from some central policy decision, but maybe it just at a high level, like where are my policies, and what type of how can I implement or manage my policies in Agent Gateway?
Yeah, so there's a good question. There's the answer starts with enterprises are very fractured in how they administer these types of authorization policies, network level authorization policies. They might do some in F5, they might do some in the application, they might have some aspect of it in Active Directory or Okta or whatever. It's kind of all over the place. When we go in and we have to fit into an environment like that, we start off with, all right, well, how can we apply these policies if we don't know what are the identities, what are the pieces that need to flow into a system like this? Start with the basics. If you're connecting up a system and the user's sitting there, well, we got to know who the user is, right? Tie into the IDP. If it's a server environment, we can derive agent identity. We should know who what agent it is and who it's acting on behalf of. And then once it gets into the gateway, we have a couple of options. Out of the box, Agent Gateway can specify authorization policies expressed with CEL, the common expression language today. And so we can write these policies and enforce them in line in the gateway very fast. And that's one option. The other options are you can call
I just like
out.
to point out that CEL is a really good and flexible policy. It's like an evaluation syntax that you might put in an Excel macro. If this blah blah blah, then return. But it's not actually a policy syntax per se. And also, if you're using CEL, then it's might or might not be externally managed. So it depends how you get that CEL. How does that CEL get approved, published, and then incorporated in as policy? So it's a good sort of solution for maybe a company that doesn't have central policy management. But a lot of companies are moving to centralized policy management systems like OPA.
And we see that.
Yeah.
We see that. So CEL is sort of a, hey, can we do fine-grained attribute-based authentication or authorization in the gateway as fast as possible? Then that's one option.
Let's make it concrete. Can we give an example of a CEL policy that we might have?
Sure. So you can build a CEL policy that says this user in this particular group with these entitlements that we pull out of the, let's say, a JWT, with this agent identity, SPIFFE-based identity, for example, or some class of identity. Maybe it's an AI agent in the finance department or something, or it's this very specific agent. Is trying to call this MCP server, this particular tool with these parameters, right? So in Agent Gateway, we can say this combination of user and agent is allowed to see this tool, and they're allowed to call it, and we can filter out and say, all right, well, for these parameters, maybe you should go get human approval or something.
It's a little messier than that, I think, because and OpenID has a new standard called AuthZen, and it's an authorization standard that standardizes the shape of the authorization request as PARC, Principal Action Resource Context. And so in that sample policy you're telling me about, we're talking about the context requirements, a token that says that you have a claim that says you're in this group, or a contextual environment that says you're coming from this network segment, or that you perform this type of authentication. But the action and the resource are actually not implicit in the CEL policy, the action and the resource are derived from where you're putting the cell policy, right? You're putting the cell policy in the post, so I don't know, the cell policy itself sort of tells you the condition, but I can't actually like factor out the action resource by just looking at the cell policy, can I?
Well, I mean, in Agent Gateway, you definitely can write policies that say that this class of user with this set of attributes is allowed to see or not see these MCP tools or these MCP servers, and call them.
It'd be
So
interesting to see if
cell.
you could put that in Park format, because if you put it in Park format, then we know that we can run this query against any conformant PDP. And I think Cell is so flexible. Cell is almost a Turing complete programming language. It has some constraints that allow analysis, so it's not Turing complete,
Yeah.
but it's almost there. It has iteration, for example. Um, and
So
so
cell is one option, right? So
yeah.
cell is what can I do when I don't want to call out, and I want to build all these policies and feed them into the gateway. So, but there's two other options. One is we can call out. Auth-Then is one protocol, but we borrowed Envoy Proxy's XAuthZ protocol, and so we can give the policy engine all of the context about who's calling, what are they trying to call, additional auth context, et cetera, and let the policy engine, like OPA, for example, OPA has an XAuth adapter out of the box, and you can call into an OPA shaped system. We can do the same thing with OpenFGA and any of those policy engines. That's the second option. The third is, at least on the enterprise side at Solo, we built a way to dynamically load in things like OPA policies or CEDAR policies and evaluate them directly inside of the gateway. So a big part of the question is going to be, how do you manage your policies? How do you structure them? How do you make them available? Are they all running in a big centralized system? Do you publish them as packages that then get pulled into other systems? And so we kind of have to fit in a number of those very heterogeneous worlds and support a variety of ways to do it.
Right. And I think that's the right position, is creating a lot of options, because as you mentioned, there is no standard enterprise approach for authorization today.
Right.
And it is very much a lot of, actually, the standard, I would say, is that enterprises have one of everything.
Yes. Or multiple of everything. Yeah.
Yeah. So I want to show, we don't normally show graphics on this, but this is an animated graphic on a post recently. It's our first time ever animated graphic. And for the benefit of people who might be listening to this, it's a diagram called Credential Brokering for AI Agents. And it's showing, it's a sort of simple diagram. On the left, we have an AI agent talking to Agent Gateway. And an Agent Gateway is using a credential vault to then connect to other services like LLMs or MCP servers. So I think the point here is that the AI agent is not able to see the credentials.
Yeah.
And so in the LinkedIn post, you say we cannot give agents credentials. My question there for this is like, is it that we don't want to give agents other people's credentials? Like, we don't want impersonation, because impersonation is well, we can't tell the difference between the impersonator and the entity.
Right.
But it's not that we don't want agents to have credentials, because we also need accountability. So don't we want the agent to have its own credentials? So it's not that we're taking away credentials, but we just want to make sure that we want to move away from sharing secrets and sharing credentials that enable impersonation.
We don't want to give, well, yes, 100% agree on that last point that you made. In agents or no agents, right? We don't want to do that anyway.
Yeah, true.
But specifically for AI agents, I mean, because this is the real, possibility that I keep coming back to is you give, I'll give you an example. I run OpenClaw, and as part of configuring OpenClaw in the OpenClaw.json, you give it, your environment variables or text files or whatever, you give it the API keys to various services that it might call, messaging services, MCP servers, GitHub, that kind of stuff, LLMs, and the OpenClaw harness has access to the file system. It can access to the environment variables and can see these types of things and environment files. And what's to say that in solving a task, a problem that it wants to do, it doesn't copy and paste some of those API keys and put them and just post them on LinkedIn. It has access to that. So if any of those keys can be leaked, and the agent has more of a propensity to do that, because it might think, well, I don't know how to do this, but maybe if I ask LinkedIn followers, hey, can you go do this for me? Maybe it thinks that's the right way to do it. So obviously prompt injection, all these other attacks that can happen, but even not even that way, just the agent thinks that's the right way to do it. So the point of that blog post was an agent has to do stuff. An agent has to, maybe it will read LinkedIn, maybe it will call out to a messaging service to post a message, but it shouldn't have the credentials directly to do that. When the agent tries to make that decision, try to call, what we want to do is, number one, evaluate whether or not the agent is allowed to do that. And then if it is, transparently inject those credentials on the way out in a controlled way. That way, the agent itself has to have something that identifies itself, but the actual credentials to go do something, long or short-lived, the agent shouldn't be dealing with that directly. That's the point of that blog.
I'm just wondering if we move the okay, so now the agent doesn't have the credentials, but Agent Gateway has the credentials. How do I know I can trust Agent Gateway any more than I can trust the agent?
Agent Gateway has access to get the credentials when certain parameters are true. And so that blog post is actually a three-part, third part I haven't written or haven't published yet. But the point of it is exactly the line of thinking and reasoning that you're going down, which is, all right, now we've moved all of these credentials into Agent Gateway. What if Agent Gateway gets compromised? And that is a real attack. We've seen that happen with other gateways. So the second part of that blog goes into, all right, well, Agent Gateway can only get access to a credential if another a policy engine has evaluated that this is a fresh request, this is Agent Gateway, this is this specific user, and we'll give you just the key, or we'll give you just the permission to decrypt that specific credential for that specific user at that point in time. Otherwise, if it's just Agent Gateway gets hacked, and an attacker makes it in to the Agent Gateway process, or actually the controller that has access to the vault and the keys, what can they do? So in the second and third part of that blog, we say the controller, or the thing that has access to the keys, does not have standing decrypt permissions. They can't. If you're going to attack the system, you're going to have to compromise the gateway, the controller, and the policy engine, all three at the same time. Otherwise, you can attack the gateway. Gateway doesn't have access to the decryption process anyway. You can attack the controller. It doesn't have decrypt. The only thing that can issue decrypt is the policy engine, and that doesn't have access to the database. So there's an architectural, least privilege type approach that we take to having to solve that. But yeah, it becomes a little bit more complex, or maybe a lot more complex. But the alternative is the agent dealing directly with these credentials, and I don't know if that's the right approach.
And so just to ask sort of an obvious question here, the agent is running on your laptop, or it's running on an endpoint that might or not be managed by the enterprise, right? The agent it could be running maybe in a container, in a pod, but it also could be running on an endpoint, like a non-managed endpoint, right?
Yeah.
Okay, there's two more points. So we're running pretty close on time, but I'm going to try and get these two questions in. The first one's on the RPs. We talk a lot about the agent and the agent gateways, but what do the RPs, the API gateways, and the MCP servers maybe need to do differently to support these more complex security situations we're running up against?
All right, so that can go in a bunch of different directions. What do you have a specific angle there?
I guess, and maybe we don't have time to maybe we don't have time to fully answer this, but I just think sometimes we forget about the RPs, the consumers and what do they need to do to better secure? For example, do they need to support transaction tokens, or do they need to support different types of token exchange or policy management? Because it seems like we can't just tell the MCP servers and API gateways, okay, it's business as usual. Just do it how you always did it. There has to be a better solution, and a lot of times the challenge in adoption is not in the central point. It's at the edge. And so I'm thinking that the edge here is the API gateways and MCP servers of the world.
So the actual resources, so the gateways themselves, I think the AI agents, one way an AI agent is different than a traditional microservice or app is that when the microservice or app makes a call, that is we know and understand what somebody wrote that service, and it's going to do XYZ if it sees ABC, right? So we can reason and understand that, yeah, we told it, we wanted it to do this under these conditions. We've given it these credentials. And so when it makes a call through the API gateway, then we have to check, do you have valid authority to do this? And we let it through. And then the backend resource can be simple enough to say, well, either the gateway let it through and I trust that, or I get the credentials too and I make an evaluation and this looks good to me. With AI agents, I think that changes quite a bit, because you can have an agent that has the access and authorization to make a call, let's say to send an email. You have the token, looks good. API gateway says, yes, it looks good. The backend resource says, yeah, I got a token, so let it through. Another one could be delete a database. Delete a database. I have the token, so I can delete the database. Now, an agent gateway or an AI gateway could be in that loop and say, or in that call path and say, all right, well, by calling out to a policy engine, we determined this is a very risky operation. I know you have the token that says you can do it, but we've decided at that level that you need additional checks. You need a human or something to further evaluate whether this is allowed. The resource could say, all right, based on your credentials, I see you have the credentials to delete the database, but you're an AI agent, and I don't fully trust you. So what I'm going to do is evaluate rules on the resource side that says, well, this database is being used by a number of people right now. This has a classification of, PII or sensitive or whatever. And I see you have the right credential, but I'm not going to do that. I'm going to challenge that. I'm going to send back a challenge token that says, this is what's trying to happen. Go get approval for that. Or it says, all right, I'll delete it, but I'm going to take a snapshot of this and make it recoverable. Because I don't fully trust. This is an AI agent doing this. I don't know if I fully trust this. So there's a number of areas in the call path where we can try to identify or fit intent. Going down that path gets really murky. But there are controls for doing that. If it's a financial transaction over $10,000, we can detect that and say, all right, well, we know we need a approval for that. But for these other squishy things that, trying to map intent to concreteness is very difficult. But we can build in safeguards on the resource side. There's a number of things that I think slightly change, or maybe quite a bit change, on the resource and gateway and relying party side that the AI agents are forcing.
I'm just going to quickly show, you raised an interesting point about what I think is really zero trust. Mm-hmm. So this is from my talk at MCP Dev Summit. Hold on, let me switch to it. Basically, the idea is that we have an agent talking to a gateway, and then the gateway is talking to MCP servers or API servers. And maybe, let's say, the MCP server might be calling an API server. Mm-hmm. And that API server might be in a huge SOA and calling lots of microservices, which are connected to databases. Mm-hmm. Now, the idea of zero trust means that we don't trust the agent gateway, because although it's good that it's doing security, we can't really be sure, right? Zero trust basically says we can't trust one point to do our security, so we need policy everywhere. So we need policy in the MCP server, in the API gateway, in the microservices, in the database itself, in the IDP, should we issue these tokens. So policy ends up being everywhere. And the agent gateway is a convenient place to enforce security, but it's not going to be a panacea for security, and it's certainly not going to get you zero trust. Whenever I see zero trust gateway, zero trust like a gateway solution, I'm like, do these people know what zero trust means? Like literally, you cannot have zero trust if you have a gateway, because that's the meaning of zero trust, is we don't trust one point to do the security. So it makes me wonder if yes, it's a convenient place where we can do a lot of interesting things to improve security, like switching tokens or vaulting credentials or observing. So it's an essential piece of infrastructure. But I wonder, and coming back to the title of the show, because I always like to make sure we get in the title an explanation. It says Agent Gateway, keep infrastructure out of your AI agents. So I'm wondering if part of the point here of the Agent Gateway is not to enforce security, although that is an important goal, but also to create a level of abstraction that hides some of this infrastructure complexity from the agent, so it doesn't have to track all this stuff and know. I guess relating back to our original question, maybe 5 years from now, will putting all of these details into agents look as strange as like putting the load balancer information into an API today?
Well, yeah, that's the title of this session and the angle that I've been coming from is so security is difficult to get right. That the gateway can offload a number of critical things that an agent or any service would need to do. The gateway itself is not meant to be this one centralized thing that everything has to flow through. Honestly, I think that's an anti-pattern, to be honest. And we haven't really talked about architecture and how you would deploy this and so on. We come from the world of, or I do come from the world of, how do you make that blast radius of the, of the trust in the system as small as possible? It doesn't go away, but you make it as small as possible. Authenticate, authorize, audit all of the requests that are going through. And a gateway helps to offload the mechanical pieces of doing that, especially in a world where you're not going to trust the agent as much. So that's I think that both principles are compatible, and happy to go into more detail on architecture.
Yeah, well, pigeons are flying, so I guess we'll go into last thoughts. We can't solve the life, the universe, and everything in one IOH episode. So hopefully, I would say MCP's Dev Summit is coming up, so I'd encourage audience to attend. And Christian, will you be at the San Jose one that's coming up?
Yeah, so the AAIF AgentCon, MCPCon, I'll be at the one, and I'm speaking in Amsterdam in September about what is agent identity. I'll be speaking at the San Jose one with Lynn Sun, I think on this topic, the removing infrastructure from your agents. And then I'll be at KubeCon, Salt Lake City, speaking about agent substrate and running agents inside of Kubernetes.
So audience members can accost you directly for more questions. Any last thoughts before we wrap up?
I appreciate the time. Working on all these hard, difficult problems at Solo, leading primarily through the open source communities. That's kind of where we do a lot of our stuff there. I have an announcement next week, a little bit more on the desktop side of things, and and more after that. So reach out. I'm on LinkedIn. I write and publish a lot. So but again, Mike, I appreciate you taking the time for this and inviting me.
And just a quick announcement about next episode. Imran Siddiqui, who is one of the contributors to the Agent Gateway Toolkit, which was started by Microsoft, and now he's joined some new startup, which he'll talk about. But he's been really a leader in agentic governance.
Agent Gateway Toolkit or Agent Governance Toolkit?
Agent Governance Toolkit. Did I say Agent Gateway Toolkit?
Yeah.
I have Gateway on the brain today. Agent Governance Toolkit.
And I published a blog integrating Agent Gateway with Agent Governance Toolkit.
Yeah, AGT. So it should be a good episode. One last quick reminder, follow us on LinkedIn, YouTube, and now Spotify. And with that, I'll say, Christian, thank you so much. We ran a minute or two over, so thank you for hanging in there.
Yeah, I appreciate it. Thank you.
And thank you.